Good morning, friends. Let's start with another chapter of the same introduction to computer. Here we are come with the primary and secondary storage devices. So what exactly the storage devices we have seen in the last classes? Basically, there is a different kind of a storage devices like your hard disk, your floppy drive, your CD-ROM. These are the devices in which we store data. Basically, storage devices is those devices in which we store some data. Just like your RAM, in which we are temporary systems temporarily store the data. Or we have a ROM, read-only memory, in which also their system is storing the data. Your hard drive. So there is a different devices available in the market and your system in which you store data. So basically, it has been bifurcated in two parts: primary and secondary storage devices. Some of the devices which is primary for the system, those are called primary, and which is are not primary, those has been taken as a secondary devices. So what is primary and secondary devices? What are the difference in those devices? We are going to see over here in this chapter. So introduction. The purpose of the storage unit of the computer is to store the data entered before processing and also to store the results after the processing. So there is a two tasks we have seen over here. Before processing, obviously you need to store some data, and while execution your system, while execution your program or something else, also you require the particular results has to be stored somewhere. Suppose you are running running some database, so you want to store those database in somewhere. So before execution and after execution you need to store those data in somewhere, some places into the system. So these are nothing but a storage device which basically stores those data. So physical devices used to store programs or data on a temporary or permanent basis used in a computer. So I have told you, when you're writing anything in your system, so it will temporarily store initially into the RAM, because that is a temporary storage devices, and after that it will go to the your ROM, which is a basically permanent storage device. So after RAM it will store into the ROM. So there is a different kind of devices in which some permanent storage and in which some temporary storage. So memory data are stored in the form of chips, storage data stored in the tapes or disk. So whatever the data is stored inside there, it is form of a chips. So and storage data stored in the tapes and disk. So anyhow, whatever the data has been stored in devices only in two, either it is stored in the primary device, either it is stored in the secondary device. There is no other device in your system. So organize, there is a storage unit, two storage unit. I have told you primary storage devices and secondary storage devices. So primary storage device or random access memory, which is called RAM. So primary storage device is nothing but your RAM. Might be in the question paper they will ask you what is a primary storage device. There you will get a 4 option: RAM, ROM, hard drive or something else. So you need to choose RAM. It is a primary storage device. The term random access means that any word in the memory may be accessed without having to go through all the other ways to get it to. So random access in the sense you can randomly access that particular data which is stored inside a RAM. It can read and write. You can read and write both. You can easily read and you can write in the RAM. Memory consists of integrated circuit either on motherboard or a small circuit board attached to the motherboard. We have seen when we are saying computer components, then we have seen the RAM. RAM is a very small, I can say the circuit kind of the circuit which basically attached with the motherboard, and that particular circuit we can use in different slots in the motherboard itself, and there is lot of slots available if you want to increase your RAM. Basically, nowadays in any device you will get at least 1 GB RAM, 1 GB minimum, and if you want to increase your RAM, you can increase as per the requirement. Because there is a lot of software, very heavy software basically, which is used in the heavy industry and different other industry like your ERPs and all. They are not running if you're they are not able to run properly if you're not using high storage RAM. If you're using very low storage RAM like 256 or 512 MB, then it will give you the difficulty to run those particular ERPs. So nowadays in every industry they are using high storage capacity RAM, which is minimum 1 GB, and it is increased by 1, 2, 3, 4, and 5, whatever the requirement. So in the motherboard itself, there is a different slots in which you store the RAM. Basically, the hardware engineer will store the RAM over there. There is a slot available, and it is nothing but an integrated circuit kind of device. So when you store RAM inside a motherboard, whatever the data is there, it is stored inside a RAM. So we will see the picture of RAM. You can see this is the RAM, basically very thin, and it is these are the circuits available over here. You can see, and this is a place in which is integrated inside the particular slot and in the motherboard. So you can see this is the RAM. If you want, you can check it out in your CPU also. You can open your cabinet and you can check it out. You will find out this RAM in your CPU cable. So then RAM can be two types. There is two kind of RAMs, which is called dynamic RAM and one is called static RAM. So we call this DRAM and SPRAM. So DRAM and SPRAM, which is a dynamic and static RAM. So starting initially with the dynamic RAM, it only holds data if it is continuous access by the refresh circuit. So dynamic RAM only holds the data. It will not do anything. It will hold the data for your as per the requirement. Many hundreds of the times each second this circuit reads and then rewrites the contents of each memory cell. So it is reading and writing both. It is doing the reading, and anytime if you want to write again and again. So it is doing reading and multiple time writing you can use over here with the help of dynamic RAM. Then it is slower and more complicated. So it is slower. We have seen it is slower as compared to the static RAM. It is cheap and take up much less space, typically 1/4 of the silicon area or SRAM or less. So basically, if you are going to compare, it is taking very less amount of area as compared to the static RAM. So dynamic RAM is taking less area as compared to the static RAM. So there is a difference in the question paper. If they will ask type of RAM, so you need to write two types of RAM: dynamic RAM or static RAM, and then these are some differentiation while you doing the differentiation of dynamic and static RAM. So it is used in a primary storage. Basically RAM is a primary storage, so it is work as a primary storage. It takes 120 to 200 nanoseconds to read from a write into the any location. So you can see the time is very much less. You cannot calculate 120 to 200 nanoseconds. Nanoseconds is around very less time which we cannot calculate. So you can understand the timing is too less, and it require very less area as compared to the SRAM, and only it required 1/4 of the area of the SRAM. So these are some, I can say, the functionality of the dynamic RAM. Let's see the functionality of the static RAM. So these are the static RAM. It is also volatile storage device. It is a volatile. These chips are more complicated and take more space. So as compared to the dynamic RAM, you can see it required more space. So static RAM require less space dynamic RAM require less space as compared to the static RAM, and vice versa. It is used for in a specialized application. Static RAM it cannot use in each and every devices. It has been used in some specialized application. It is a fast and accessible 80 nanoseconds read from or write into any location. So it is very fast. It is take 80 nanoseconds. So as compared to the dynamic RAM, it is faster. Static RAM is faster than the dynamic RAM. It is expensive as compared to the cost wise. Static RAM is expensive than the dynamic RAM. These are some functionality of the dynamic RAM. So you can now easily differentiate between static and dynamic RAM. Now we are going to the ROM, which is called read-only memory. ROM, read-only memory. ROM is built-in computer memory containing data, and normally it can only be read, not written. So it is only can be read. it is can be not written. Built-in computer. So it is a built-in. There is no we cannot take it out, just like a RAM. RAM you can take it out from your system, but ROM you cannot take it out. ROM memory is a preset memory, as I've told you. ROM is one of the which information are stored permanently. In the RAM, we cannot store the data or any information permanently, but in ROM we are storing the data permanently. The access time for memory is very fast, so as compared to the RAM, it is faster. ROM is very expensive to design and manufacture. So as compared to the RAM, it is designing is complex and cost is high and it is expensive in design. So these are some functionality of the ROM. So we have seen RAM and ROM. So you can easily compare RAM and ROM now. So read-only memory and random access memory. That is a primary. This is a both are the primary memory, and it is a preset memory. That is not a preset memory. There is not inbuilt memory. You can easily get it out. ROM is one which information is stored permanently, but there we cannot store the information permanently in the RAM. Its access time is very fast. So RAM is not as much fast as the ROM, and cost wise, ROM is more costly than the RAM. This is the kind of ROM you can see, read-only memory. ROM is non-volatile memory. RAM is a volatile and ROM is non-volatile memory. It has continuous source of power and do not need periodically refresh. So it is getting continuous source of power. There is no need to give attention on the power side. Under ROM comes PROM, EPROM, EEPROM and EEROM. There is four kind of ROM, just like we have seen. In the RAM, there is two kind of RAM, dynamic and static. There is a four kind of ROM, PROM, EPROM and EEPROM and EEROM. So we have seen, we can see these kind of four types of ROM in the next. Starting with the PROM, which is called programmable read-only memory. So PROM is nothing but your programmable read-only memory. PROM are programmed to record information using a facility known as PROM programmer. So with the help of program, you can storing the data over here. So EPROM is programmable in the sense of program. There is some program which is basically helping out to store the data. The recorded information cannot be changed. Whatever the record information you have kept in the programmable ROM, it cannot be changed anyhow. It is non-volatile storage because RAM or ROM itself is a non-volatile. So it is a non-volatile. Example, video games, mobile phone, etc., where we are using programmable read-only memory in the video games and mobile phones. Erasable programmable read-on, EPROM in the sense of erasable. It was developed to allow programmers to reprogram permanent read-only chips. So it is allow the developers to reprogram permanent read. It will permanent for reading purpose, will be permanent. It is erased and reprogrammed by exposing the inside of the chips to ultraviolet light. So with the help of ultraviolet light, these are the exposing. It were used in the old IBM PCs and XTs for storing the BIOS information. So basically, if you find any notebook, old notebook of IBM, you will find erasable programmable ROM have been used over there, and basically storing the BIOS information, which is basic input output system information, will be available in the erasable programmable read-only memory. Electrically alterable ROM memory, which is another type of ROM, which is electrically alterable ROM. So memory can be programmed and erased by electrical signal. With the help of electrical signal, it is erasing the memory, erasing the data, whatever that has been written over there. It does not require exposure to UV light to erase its contents. So it is not required any UV rays, which is required in our in the programmable and another one. So there is no required for ultraviolet light. It provides easy means to load and store temporary or permanent information in form of ROM memory. So it is easily loading. It is easily loading into the ROM. There is no need for any effort putting kind of stuff. This memory can be retained for many years without any power supplied. So like our hard drive, if you keep hard drive for long time, whatever the data is available inside your hard drive, it will be available. If you are not providing any kind of supply, power supply over there, it is backup of a RAM memory. So it is a RAM backup of RAM. So electrical alternative ROM is backup of RAM. A special form of EEPROM is flash memory, which is your flash memory you have seen in the system, that is nothing but your EEPROM. Electrical erasable memory, EEPROM, it allows to erase the ROM chips on the fly. It allows to eraser of a ROM. It sends a series of special electrical signals through the chips, EEPROM chips. So it is sending the electrical rays in the EEPROM. EEPROM chips is often referred to use as the CMOS BIOS chip in the computer. So basically it is used also for BIOS, which is available into your while you starting your OS, then BIOS will run in your system. So it will basically use for BIOS. Information erased by electrical pulse, be flash memory. So it can be a flash memory, whatever the information is available, it can easily erase with the help of flash memory. So it is nothing but your EEPROM. See, actually in your syllabus only ROM and RAM is available, but is there. But I am extending what exactly the types of RAM and ROM I am including over here. Then we are come with the secondary storage devices. What are the secondary storage devices? This section of the memory is also referred to as a backup storage. So whatever the backup storage is available is called your secondary storage devices. The storage capacity of a primary storage is not sufficient to store the large volume of data. So we are using basically your primary storage device is not able to store much data. If you want to use some TB and more than that, so you have to use secondary storage devices. Secondary storage, also known as the external memory or auxiliary storage, is not directly accessible by the CPU. So you can use some external hard drive, available in the market nowadays. So you can utilize those, and those are you can say the secondary storage devices, which is used externally into the system, and you can store the data directly from the system to the external devices. Whatever the data you want, you can utilize, because nowadays what happened, a lot of the people are storing data into the secondary storage devices, and they cap the secondary storage just like external hard drive with in their bags and luggages, and when they want they can directly attach a secondary storage device or external hard drive into your system or laptop, and they can access data from secondary storage devices. So secondary storage devices like your hard disk, your floppy disk, your compact disk, your tape drivers, DLT, digital linear tapes, DAT, digital audio tapes, and micro vaults, USB, which is called USB devices. So we will see hard disk. Starting with the hard disk. So hard disk, we've seen hard disk has a storage capacity of hard disk has storage capacity of starting from the 8 GB up to not 40 GB. Now it is increased up to TB, 1 TB and 2 TB is coming right now. CPU use the hard disk to load programs and data as well as to store data. So we know that CPU basically use the hard drive to store the data permanently over there. So hard drive basically can be used to store data permanently, and this hard drive inside your CPU, as well as you can use hard drive, external hard drive basically, which is help out you to store data apart from your internal hard drive. So you can store, internal hard drive, you can store data about 1 TB or whatever you want, and apart from that, external hard drive also have a capacity to store data more than 1 TB and TB. So it depends on the requirement, how much requirement you have for the storage purpose for your data, and according to that you can utilize different kind of hard drives and store the data. It depends on your requirement and your data gathering. To prevent hard drive crash, must operate to PC within a dust-free and cool room. You require very cool room, you know that, where the system is running. There should be an AC or all, because if created heat over there inside your system, and it may be crash. So we require the system which is where the system is are there, the room should be very cool. So these are the hard drives. This is the hard disk. I think this image is very small, blurred a little bit, but you can see these kind of hard drives picture inside your Google. Also, you can go through the hard disk images, so you will find different kind of hard disk images. Floppy disk. Initially, in I think in 90s or in 2000 till 2005, 6 or less than that, 3, 4, we are using the floppy disk. Nowadays, we are not using floppy disk because we have the floppy disk storage capacity is limited, but nowadays the data is too high. We require to store a lot of data in the some external devices, so we are not using basically a floppy disk. We are using some pen drive or some external hard drive, something like that, which store data at least 1 GB minimum, because even if you want to store some movie, it will require 750 MB to 1.5 GB. So, and floppy disk don't have a capacity to store this much of data, so that's why floppy disk is obsolete now, I can say that, because no one uses floppy disk nowadays, because the storage capacity of the floppy disk is very much limited, and nowadays the data storage, all the data storage devices require a high capacity storage. So it is a flexible circular disk of diameter 3 inches made of plastic coated with magnetic material. If you want, you can see in the googling, you will find the floppy disk in which a plastic cover, it will cover with the plastics. The body of the hard floppy disk is with plastic, and there is a slot available in your CPU in which you're putting your floppy disk to store something. It is a square plastic jacket. It can store around 1.4 MB of data. So 1.4 MB is nothing. There's nothing like that. So nowadays, I don't think so any CPU is having any slot for the floppy disk, because initial days there was a floppy disk slot available into your CPU, but nowadays I don't find it. So floppy disk is no more using nowadays because of its storage capacity. Data recorded on a floppy disk is read and stored in a computer memory, correct, by a device called floppy disk drive. So there is a floppy disk drive available in your CPU, in which there is a one slot in which you store the data for a floppy disk drive. Some of it has a limited lifetime. Lifetime is very much limited because the capacity of the storage, this storage device is very much limited. It has to be recycled periodically to keep them alive. It is recycling because whatever the data you have used, you need to erase those data, and again you need to overwrite some other data over there. A frequently recycled floppy will have the lifetime of 3 to 4 years. There is not much, I can say, the life of any floppy disk. Maximum 4 years any floppy disk can be used, but if you're using any external hard drive or pen drive, you can use a lot of time. I mean to say the it will not give you any error or any damage over there, so you can utilize those external either external hard drive or any pen drive. So these are something about the floppy disk drive. This is a kind of floppy disk drive. You can see this is a square, rectangular or square area kind of stuff, and you can see this is the plastic coated over here, and there is a floppy disk slot available in your CPU in which you push this floppy drive, and you can store the data over here inside a floppy disk. And when you want to retrieve those data, you can also retrieve those data. Now we have a compact disk which is called CD-ROM. We have seen the simple CD in which there is a movie, there is songs. Same CD-ROM uses a laser cam to record and read data along spiral tracks of 51 by 4 disks. So this is a kind of storage devices in which laser cam is to record and read data over there. A disk can store around 650 oblique 650 MB of information. So at minimum 650 MB, and nowadays you're getting a CD drive which have CD-ROM which have a capacity of more than 1 GB. The CD-ROM are normally used to store data as backups. So these are the data basically we are using for backup purpose, and lots of information can be written on CD-ROM and is stored for future reference. There is, you can store and you can utilize it for the future purpose. So this is a kind of CD which we see our regular life. This is the CD. Now we have a tape drives. It is one of the oldest of information technology, tape drive. It can hold the most data on a single cartridge. Only single cartridge you have available over there, and so in which you can store with a computer. Tape drive works similar to a tape recorder in the VCR, just like VCR. The same way you can store the data in the tape drive. It is a sequential and not random access media. It is a sequential. It is not random access. It is only sequential. It accesses data slow on tape, in mainly used for system backups and regular archiving of files and stores. So regular archiving of files and basically store the data, and it can use as a backup. A couple of 100 MB to several gigabytes of information in cheap price. So it can store the data a couple of megabytes to the gigabytes in a very cheap price. So it is very cheap and it easily available into the market. So you can see this is the tape drive kind of stuff, picture of a tape drive. Now we have a digital linear tape. DLT drives are the robust and durable medium. It is a durable and robust. It released in 1991. DLT drives are very reliable, high speed and high capacity, making the DLT drives an excellent use for network. So it is basically used for network backup. It is highly reliable and high speed and high capacity storage devices. You can see this is the Fujifilm storage tape DLT. Then we have a DAT over here, digital audio tape. It is a popular choice of tape drives. Tape drives in DAT popular, best known for digital audio recording. So it is audio recording for, it is called digital audio tapes. These drives use a recording technique called helical scanning, which is used for VCR. So it is basically using VCR, which is called helical scanning. The 4 mm tape is wrapped around a spinning read and write head. The records data is overlapping diagonal tracks. DAT tapes can hold 2 GB to 40 GB of compressed. So if you want to compress data and you want to store, so DAT is the best option, where you can compress and you can store the data. So this is the DAT, picture of DAT. So now we have a microvolt USB storage devices. USB storage device is nothing but your pen drive. So microvolt media plug directly into the computer's BB port and acts just like another drive. There is a port available into your system, your CPU in front side or back side for your USB port, which is called USB. It is a small, light, shock proof and most mouse proof. There is no need for you mouse and all. The device is recognized automatically when we connect to the computer. It is automatically recognized. One pop-up will come over there in the right side of your system. It will showing that you have connected one USB drive. By connecting it via USB, the files can be transferred by dragging and dropping. Whatever the way you want, you can drag and drop, copy paste. There is a lot of option available. There is no cable or adapter needed for the device. No power cord and no driver software installed. There is nothing. Don't need to install any software. Nothing required. You can directly connect your USB and it will directly recognize by your system, and it will give you the hint that you have connected some any USB, and it will easily copy the data. It is compatible with both Macintosh and Windows operating systems. So it will working in both Apple and your Windows operating system. PowerPoint presentation, digital photos, MPEG videos and MP3, whatever you want, you can store over there. This is some I can say that USB drive, which is 16 GB, 8 GB and 4 GB. Nowadays it is available more than 1 TB also. So this is all about our storage devices, primary and secondary storage devices. We have completed it out. Now I'm going to start about the programming, concept of programming, and what we have learned, what we need to learn about in the programming itself. So introduction of programming languages. So you know that there is a different kind of language in the programming. It's like first generation, second generation, third and fourth and fifth. So different generation has come out from the programming, and from first generation to till fifth generation we are working over here. Different languages we are using, just like starting with the COBOL, Pascal, and nowadays we are using Java and .NET. So each and every year has been changing year by year, and there is a lot of developers has to done lot of practices and lot of hard work to develop these kind of programming languages, and they will available nowadays in the market, and most of the organization are using nowadays fifth generation language, which is nothing but a Java, .NET and some other programming languages. So we'll see what is the programming language, how we are writing the program, and what the loops holes in the programming languages. So each and everything we are going to check over here, starting with so programming language concept. What is the programming language? What are there's so many programming language? What are the types of programming language? Does the world need any new languages, or all of these stuff we are going to see over here. So what is a programming language? A programming language is a set of rules that provide a way to telling a computer what operation to perform. So basically a set of rules, a set of information we are asking to the computer that you need to do this, you need to do that. So for that we are writing some rules which has been understood by the system itself. Then they can operate on the basis of this set of rules. A programming language is a set of rules for communicating an algorithm. It is because if you want to communicate with your system, then obviously you require some algorithm and kind of stuff. So it is that it provides an linguistic framework for describing computer. So we require some framework so that computer understand my words, my thinking, my communication will easily understood by the computer. So we require something mediator, I can say that, which work between my user and the computer, so that whatever I want to say computer can understand. So with the help of that mediator, or computer can easily understand what I want. So a programming language is a notational system describing computation in a machine readable and human readable form. So what I want to know, I want to see, I need to understood to the computer, and on the basis of that I will get output or results. A programming language is a tool for developing executable models for a class, for a problem domain. So there is a executable models for a programming model, so it will use class and all those stuff. So what is a programming? English is a natural language in that it has words, symbols and graphical rules. A programming language also has a words, symbols and rules of a grammar. You know that. The grammatical rules are called syntax. Whatever the rules are there for grammatical rule, it is called syntax. Each programming language has a different set of syntax rule. Each programming language has a different set of syntax, which is called different language has a different set of syntax rules, different kind of rules over there in the programming language itself. Why there are so many programming languages? So you can do, why does some people speak French? Programming language have evolved over time as a better ways have been developed to design them. So there is evolution has been starting from last 50 years. So year by year, programming languages has been evolving from first generation till fifth generation. First programming language was developed in 1950s. So almost I can say that 50 around 68 years back, 60 or 70 years back, 68 or 70 years back, first generation language has been evolved. Since then, thousands of language has been developed. Different programming language are designed for the different types of programs, whatever the see, as per the requirement, we are selecting our language, and on the basis of that, we are writing our program. Requirement is very much important. On the basis of requirement only, you decide which language you have to use to write your code or program. So these are the some basic things. So you can see the level of programming language. We have a high level language, we have a low level language, and we have an executable machine code. Executable machine code is in only 0 and 1 form, 0 and 1 form. There is nothing else. But low level language in which we are easily writing a, I can say, code in which it will easily understood by the system, which in which just like load r1 comma b, load r2 comma h. MUL stand for multiply r1 to r2, divide r1 to 2, and read results. Like that we are writing over here. So in which this is a system in which it will load r1 like binary data, load r2 some h data, then it will multiply r1 and r2 over here, and then divide r1 to r2. So like that it has been written, and after that it will require a result. So it is a low level language. And then we come with the high level language where we are using class, we are using some float variable, we are using return. So same way, something in which we are designing some pattern and all. On the basis of that we are writing some code or programs in high level language. So these are the three: executable, machine code, low level program, and high level program. So what are the types of programming language? I have told you first generation, second, third, fourth, and fifth. There has been 5 generations till now from 1950 onwards. So right now in the 5th generation language we are using Java and .NET. So starting with the first generation language, which is nothing but your machine language, which is called machine language. Operational code such as addition or subtraction we are doing over here. Operation in which we add something, we subtract something. Operation operands that identify the data to be processed. Operands which is identify what data should be. Operands in the sense you need to add something, you need to divide, subtract, like that. Machine language is a machine dependent. It is only language that computer can understand. You cannot understand this kind of language. Only machine, you mean to say only system can understand. Very efficient code, but very difficult to write. It is efficiency is very much high, but it is very difficult to write machine level language because it is very I can say that very complex, which is not understood by the human being, which is only understood by the system. Then we have a second generation language which is called nothing but assembly language. So symbolic operation codes replace binary operation over here. Symbolic operation we are using in the first generation language, is machine. Here we are using symbolic operation is replaced with the binary operation in the form of 0 and 1. The symbolic operation program needed to be assembled for execution by the computer. Each assembly language instruction translated into machine level language instruction. So whatever the written we are writing in the assembly language, after that it need to convert in the machine level language, then only computer can understand your requirement. So very efficient code and it is easier to write as compared to the first generation language. So second generation language is nothing but your assembly language, which is easier to write as compared to the machine level language, which is the first generation language. So these are the some different. Then we have a third generation language over here, closer to English but included simple mathematical notation. It is very much close to English. Program written in a source code which must be translated into the machine language. Programs called object code. So here object has come, in which we are writing each and every code in the object level object code. The translation of a source code to the object is accomplished by a machine language system program which is called compiler. So compiler come into the picture here, which basically converts your code into the machine level language. So compiler will play an important role over here from the third generation onwards. So compiler is there in third, fourth and fifth generation also. So compiler play a very important role over here to convert your inputs into the machine language which is understood by the machine itself. Alternate to compilation is interpretation, which is accomplished by a system program called interpreter. So we have interpretation also. In last class we have seen the difference of compiler, interpreter, assembler. So the same interpreter. Common third generation language is COBOL, Fortran, C, C++ and Visual Basic. So in which C and C++ is the most common language which is known by each and everyone. So and some other Visual Basic is also COBOL and Fortran. So these are the four common languages which is come under the third generation language. Then we have a fourth generation language which is called 4GL, fourth generation language, that requires fewer instructions to accomplish the task than the third generation. So requirement has been fewer, whatever you are writing, the code has been reduced. So you can write easily codes to understand by the machine. So used with the database, there is a database has come in the fourth generation. It's like query languages, report generator, form designer and application generators, which is used in the fourth generation languages. Then we have a fifth generation language in which we are declaring languages, functions. We have a schema, SML, Lisp, also called application. Everything is in function. We have a logic, we have a prologue based on mathematical logic, rules, constant base, each and everything is available over there. So with the help of that we are doing our fifth generation language, in which it is more simpler than the fourth generation language. So year by year I can say that when the generation is from first generation to second or third, then third to fourth, it becomes simpler for the user to write a code, to write a program, to understand by the machine itself. So year by year it will become slowly become it is easier, which is understood by the system itself. Then beyond fifth generation language, though not clear definition at present, natural language programs generally can be interpreted as executed by the computer within no other action by the user than stating their question, limited capabilities at present. So after fourth generation language, you can see the natural language has come, but it is not used thoroughly into the system, and because it is a little bit which is understood by the system itself, so it is in process and limited capacities at present. So it is in process, and it will might be in the future we'll see the natural languages, some other languages, which is whatever we are asking, it is easily understood by the computer and they will give you the results. So this is the language family tree. You can see from 1957 to till 1995, starting with the Fortran. 1957 Fortran has come, Fortran 2, then Flowmatic, then we have a COBOL. Algol is coming around 1960, COBOL is coming around 1960, Fortran 4 is coming in 1962, then BASIC has come in 1964. This is the PL SQL has come around 1963 only, and you can see this slow by slow the languages over here coming, the Pascal, Modula, Fortran 77 in 1978, ADA has come in 1983, then we have Oberon, Modula, Fortran 90 has come in 19, then Eiffel, Visual Basic has come around 19, then in 1995 the Java has come, C has come as much earlier in around 80s, 83 or 84, and 1969 or 70 the C has come. So this is the all I can say the tree of different kind of language, in which year they have come, each and everything. You can see the Pascal has come in 1971. So each and every year, how the evolution has been done of each and every language over here, you can see. So year by year, from Fortran 1 to Java, you can see in 1995 Java has come. Now the .NET has come, and different some other languages has come, and day by day it is increasing. Not it is I can say it is not reducing, but day by day it is increasing, year by year. So the principal paradigm is imperative programming, which is C, object-oriented C++. Logic declaration programming is Prolog, and functional application programming is Lisp. These are some principal paradigm of programming concepts. So here, so we have a programming language which is two broad groups: traditional programming language and object-oriented. So traditional programming language is in sequence of instructions, only instruction which is given in the sequence, first, second, and some third generation. Till third generation language you can see the traditional, and fourth onwards objects are created rather than sequence of instructions. Some third generation and fourth and fifth generation languages. So a small amount of third generation, and from fourth generation onwards we are using OOPS concept, which is called object oriented programming concept, instead of traditional programming language. So traditional programming languages like Fortran, we have a formula translation. Fortran is stand for formula translation basically. Developed at IBM in mid 50s, designed by scientific and mathematical application by scientists and engineers. So it is designed only for scientific and mathematical calculations, applications, not much. Then we have a COBOL, which is common business oriented language. Is called common business oriented language, COBOL. Developed in 1959, designed to be common to many different computers in that time, typically used for business applications and all, not much. Then we have a traditional programming languages continued, which is basic, beginners all-purpose symbolic instruction code, developed at Dartmouth College in mid 60s, developed as a simple language for students to write, and programs within which they could interact through terminals. So there is a different terminals in which programmers can understand, and they can easily understood about the basic of the programming, the beginners all-purpose symbolic instruction code, which is a full form of BASIC. Then we come traditional programming languages, which is C, which is developed by Bell Laboratories in around early 70s or after 70s. Provide control and efficiency of assembly language while having third generation language features. We have a third generation language features over here. Often used for system programs. Has been used. Unix is basically written in C. So Unix software, which you know that it is in a kind of operating system, it is written in C language itself. Then object-oriented programming languages come from the little bit of third generation, and after that fourth generation languages entirely object-oriented. So Simula, the first object-oriented language developed by Ole John Dell in 1960s. Then we have a Smalltalk, first purely object-oriented language developed by Xerox in mid 70s. Still used on some computers. Smalltalk still they are using for some of the computers. Then we have a C++. It is a C language with additional features, with object-oriented features has come into the C language, using class, functions, all those stuffs. Widely used for developing system application software. Some application and system software we are using. Basically, it is developed with the help of C++. Graphical user interface can be easily developed with the Visual programming code. So Visual C++ we are using to develop a graphical user interface. Then we come with the Java, which is the latest one, an object-oriented language similar to C++ with eliminate a lot of C++ problematic features which is available in the C++. So that has been removed and come with Java. allows the web page developer to create programs for application called applets that can be used through a browser. So whatever the web application nowadays, we are seeing most of the web application is starting developing with the Java, and they are using, which is not available in the C++. That is a drawback of C++. We cannot use it for web application. So Java has come with a web application, different kind of web application we can use with the help of Java and .NET. Objective of Java developer is that it be machine platform and operating system independent. So there is no in any of, see, there is some language which is used basically for which is dependent on some operating system, but Java is a kind of language which is independent of any kind of any kind of operating system OS. So whatever the operating system you want to use, you can use. It will run in all operating systems. We have some special programming language, just like a scripting language. We have a JavaScript and VB script, PHP and ASP, Perl and Python, which is a scripting language it is called. Then we have a common command language is in which SSH Bash, text programming language which is LaTeX, and PostScript. These are the some other scripting command languages and text processing languages. Then we have a HTML, which is called hypertext markup language. Basically, whatever the code nowadays we are writing in for web pages, if you're designing any web page, so apart from Java, we can also use the HTML tag. With the help of HTML tag, you can easily create a web page. So used on the internet and World Wide Web, which is easily, you know, that internet and www. Web page developer puts brief codes called tags in the page and indicate how the page should be formatted. So there is a two tag has been used, which is open and close, like that, small v kind of. So in which whatever the code you want to write, you can write inside those particular tag only. You cannot use apart from that. So starting with the those tags, you have to write each and everything inside those tags. Then we have an XML, which is called extensible markup language. It is also used in the web paging, so a language for defining other languages. So it is also helpful in the creating of a web pages, and it will also work with the Java. It is integrated with the Java and creating some web pages over here. So a language is a language. You can see that a programming languages are languages when it comes to machine mechanics of the task. Learning to speak and use a programming language is in many ways like a learning to speak a human language. So initially you don't understand the programming languages, but day by day when you start working on that, you can understand very easily the programming languages. In both kind of languages, you have to learn new vocabulary, syntax and semantics. As a human beings, we are also, when you start learning suppose any new language, then you have to understand about the vocabulary, their syntax, each and everything. The same way you have to understand this programming language, each and everything over there. And both kind of language require considerable practice to make perfect. But there is a difference. Computer language lack ambiguity and vagueness. In English sentence such as saw the man with the telescope, who had the telescope, or take a pinch of salt, how much is a pinch, kind of English language we can see that. In a programming language, a sentence either means or thing, or it means nothing. So there is a something meaning or there is nothing in the programming language. That's it. There is nothing in between kind of stuff available in the programming languages. What determine a good language? Formally, runtime of a good. What is a good language? Which is there is no any syntax error. We will see what exactly the syntax error in the next. I can say next chapter. There is no syntax error. There is no any runtime errors. There is no any dump. So these kind of languages in which you will get while you're running the report or anything, you will get properly output. That is called a good language. So formally runtime performance. Computers were more expensive than programmers. So now lifestyle human cost is more important. Easy to design coding, debugging, maintaining and reusability. So these very much important. How you do. So these four things is very much important. You're designing your coding, debugging, maintenance and reusability. How much reuse can you can reuse those code what you have written over there. So there are some criteria of a good programming, good language design. So first off is ability. The quality of language that enables the programs to use is to express a computation clearly, correctly and concisely and quickly. So whatever you have written, it should be clearly understood by your computer system. Otherwise it will not, if you not understand by the system, it will give you error. So first is very clear readability, the quality of language that enables a programmers to understand the comprehend and nature of the computation easily and accurately. So it can easily readability read by system as well as any other program, because so see, while you're writing any code, so it should be very clear and very easily understood by the some other person. You have written some program, it has not been understood by some others, so it is very difficult while he is working in place of you and he are going to changing something. So if it is not understood by him, so it is difficult for him to change something and to create some new functionality over there in the existing one. So orthogonally, the quality of language that features provided have a few restrictions as possible can be combinable of many meanings. So what you have written, there should be some meaning. You cannot write each and anything like that only. So there should be some meaning while you're writing the code. So code should be very clear, very precise, so it can be understood by the person. There is a good developers who can write the code in a 1 or 2 lines, and there is a developer who can write the same code in a 8 to 10 lines. So it depends on the logic, it depends on the thinking of the different kind of developers, how they are thinking and how they are writing the code. Then reliability, the quality of language that assures a program will not have unexpected and disastrous way during execution. So it should be properly executed. There is no need of any unexpected results or any disastrous way during executions. Maintainability, the quality of language that ease errors can be found and corrected a new feature. So that's the same thing, you can add a new feature if you want to add. You can enhance your code, you can modify the data, each and everything can be easily do it while the maintaining. So criteria, generality, the quality of a language that avoids special cases in the availability or use of a construct, and by combining closely related constructs into a single more general one. So it is generality, there is uniformity in your code should be very uniform. There is some protocol should for each and every language, you should follow those protocols. So quality of languages, similar features should look similar and same behavior. Extensibility, the quality of language that provides some general mechanism for the user to add new constructs into the languages. There should be extensibility available. Standardability, the quality of language that allows programs written to be transported from one computer to another without significant change in the language structure. So you can easily use one from one system to another system, you can easily transfer. So standardability and implementability, the quality of a language that provides a translator or interpreter can be written. This can be addressed to complexity of the language definition. So whatever you have written, it can easily implement into your system. So this we have completed about the introduction of a programming language, and we will see in the next class onwards about how we are writing the code, what is the basic requirement to write a code, each and everything. So most probably we can continue this, and we'll see in the next class what we can do with right now. What better we can do with additional something, what we can